friends, in this video today we will be learning how to graph linear inequalities, listen carefully, on a coordinate plane. Now, don't be confused. We've learned how to graph linear inequalities on a number line. We have already done that, but today we're going to move our graphs to the coordinate plane. Okay, here's your heading for today. Please copy this down. I want you to write down graphing linear inequalities on the coordinate plane. Write down lesson 6.5 and be sure and include today's date. Alright, graphing linear inequalities on the coordinate plane. Lesson 6.5 and be sure and include the date today. It would be wise, in my opinion, to take a second and review what it looks like to graph an inequality on a number line. Now, you can take notes on this if you want to, but you don't have to. You might just want to sit back and watch, okay? We know how to graph this on a number line. Remember, we put our number line 0, go over to -6. Put a point there. If there's an equal sign here, then we close the point, or we shade it in. However you want to say that. If there's not a line here, then we leave it open. X is less than -6, so we draw an arrow going this way. Or we go like this and put an arrow. Okay, so that's graphing a linear inequality on a number line, correct? We've done those, right? We've graphed conjunctions, disjunctions, all of those things on a number line, okay? But now that's going to change. So having gone over that, let me quickly show you what I mean when I say that we are going to graph linear inequalities on a coordinate plane, okay? You do not need to take notes on this at all. You can just watch, okay? If you want to take notes, that's fine. You don't have to. I would encourage you to just watch. Okay, in fact, let's just do this. Let me just copy this from over here. Give me a second real quick, guys, to do something. Let me see if I have this still. Yes, I do. Good. Okay. Alright, when I say we're going to graph linear equations on a number line, it means this. You might have a line that looks like this, and then you'll shade up here above the line, or you might shade below the line. And I'm going to teach you all of this later, okay? You might have a line that looks like this. It might be a dotted line, and we'll talk about that later. And you might shade above it, or you might shade below it. But that's what the graphs are going to look like on the coordinate plane. You're going to have a line. The line might be solid, or the line might be dotted, but you're going to have a line, and then you're going to have shading. Alright? And that's what it's going to look like when you graph linear inequalities on a coordinate plane. So having said that, here's some good news. Graphing linear inequalities on a coordinate plane is exactly like graphing linear equations, okay? Except for the addition of shading. So you should not find this material difficult at all. You really should not, okay? Let's jump right into this. Please copy down the first problem that we're going to graph on a coordinate plane. 2x, let's make that negative 2x is less than or equal to 7. I want us to graph that on a coordinate plane, okay? Now the first thing you want to do is you want to graph the line, okay? Did you get that? I'm not going to give you steps today because I don't really think we need steps. But the first thing you want to do is graph the line. So off to the side, just pretend, well, first of all, if we're going to graph this line, we must first get x by itself. Alright, let's do that quickly. Notice we're divided by a negative number, so we turn the arrow there. Now we want to graph that line. Pretend you have an equal sign there. I know you don't. I know that, but pretend you had this right here. Where would you draw the line at? Remember, I've taught you if it's just one variable, if you don't have an x and a y, then you're either going to have a vertical line or a horizontal line. x-axis, and I go to 3.5 and I put a point there. And that's the line I would draw right there. Now, is it going to be a dotted line? Or is it going to be a solid line? Well, look at your inequality symbol. Do you see how you have an equal sign right here? Everybody see that? That means you'll have a solid line. If you did not have this equal symbol here, if it was gone like this, then you would put a dotted line. By far, that's the main mistake students make on these types of problems on a test or a quiz. They forget to check to see if they have a dotted or solid line, okay? So we have a solid line. Okay, it's not working. Okay, still not sure what's happening here. Okay, good. Alright, so slide that over, and there we go. There's my vertical line. Okay, we can put an arrow here and an arrow here. Good. Now, it says x is greater than 3.5. So obviously greater means to the right, not to the left. So you would shade to the right of the line. You would shade to the right of the line, and you're finished. Now what this answer means is the answer to this, the graph or the answer to this inequality is every single ordered pair going on and on upward, going on and on downward, and going on and on to the right forever and ever. That's the solution set to this problem, and there's the graph. So that's simple, guys. Let's try another one. Here we go. Let's try one that has a y only, something like this. 3y is less than negative 12. Alright, there we go. Now I want you to graph that. You can work ahead or you can watch me. First of all, you want to get y by itself, so we're going to divide both sides by y. Or by 3, excuse me. When I do that, notice I did not turn the arrow because the number I divided by was a positive number. So I end up with y is less than negative 4. Now, I know that you don't have an equal sign. I get that. But pretend you had an equal sign just for a second. How would you graph that line? Well, you would go to the y-axis, which is right here. You would go to negative 4, which is right here. And you would draw a horizontal line, correct? Okay. But notice there's no equal sign here. So we're going to put a dotted line, not a solid line. So here's my dotted line. And there we go. Alright. So, y is less than negative 4. Am I going to shade below the line or above the line? Well, common sense would tell you below because it says y is less than. Obviously, when you go downward, you're getting smaller. When you go upward, you're getting higher in the positive numbers. So, y is less than negative 4. So I'm going to shade below the dotted line. And that's all there is to it, guys. It's pretty simple. Now notice the past two problems have had single variable inequalities. If you'll look back in your notes, the first problem that we graphed had an x only with no y. The last problem that we just graphed had a y only with no x. Obviously we need to graph some problems now that have an x and a y, because these are done a little differently, okay? So here we go. I would encourage you to not work ahead. I would just watch me work on this, okay? X plus y is greater than 3. Now, if you want to get x by itself or y by itself, I guess you could, but there's really no need to do that, okay? The first thing you want to do is simply graph the line, okay? Now, I know we don't have an equal sign, but pretend we had an equal sign just for a second like this. Pretend this was gone, and pretend we had an equal sign instead, okay? would you graph this? Well, there's many ways you can do it. We've learned the table of values method, we've learned the slope-intercept method, and we've learned the double intercept method. I love the double intercept method when the equation has an x, then a y, then an equal sign, then a constant term. Okay? As long as this constant term is not 0. If it's a 0 here, never use the double intercept method. It will not work. Do not do that. Okay? So I'm going to use the double intercept method. Remember how to do that? Where the x is, we put a 0. And we get y equals 3. Then I put a 0 in for y. And I get x equals 3. That's the x-intercept. Do you remember that? Put a 0 in for y, that gives you the x-intercept. Put a 0 in for x, that gives you the y-intercept, okay? Now let's draw the line, but hold it before you draw the line. Do I have an equal sign here? No, I do not. So I'm going to draw a dotted line. Now, here's where, as a teacher, I will admit I get a little frustrated sometimes because I feel like I teach this pretty decently and students sometimes don't listen. So I'm going to say something that's really important, okay? And some of you will listen and some of you won't, okay? I hope everyone does. But here we go. In the last two problems, we had what? Not this problem here. The last two problems, we had what? Single variable inequalities, correct? The first inequality had an x only. The second inequality had a y only, correct? Single variable inequalities, okay? When you shade those, they're really easy to shade because you have either vertical lines or horizontal lines, so it's easy to know where to shade. When you have a two-variable inequality like this, you have slanted lines. Those are not easy to know where to shade. So here's what you have to do, and here's where it gets difficult. Are you ready? Write this down, please. You have to do something called test a point. Okay, please make note of that somewhere in your notes. You have to test a point, alright? Now the favorite point to test is always 0, 0. Okay? That's my favorite point to test, but if 0, 0 is lying on the line, then you cannot test that point. Now, is 0, 0 lying on this line? Not at all, so we're fine. But if the line would have looked like this, pretend the line looked like that. If the line had gone through 0, 0, you could not use 0, 0 for your point. You have to pick another point. I recommend any point on the y-axis. I personally think that's the best way to do it, but that's just me, okay? So having said that, because my point because 0, 0 does not lie on this line, I can use this point, so I'm going to test this point. So here's my x, here's my y. Now watch what I do. Take some notes on this. I put a 0 where the x is. I put a 0 where the y is. And let's see if I get out a true or false statement. 0 plus 0 is 0. So I get 0 is greater than 3. 0 is greater than 3. That's false. That's not true. So this point right here gave me out a false statement. So that means this point is no good. So if it's no good, why would I shade where the point is? That doesn't make any sense. If I know this point right here is no good, I'm going to shade away from that point. Okay, I'm going to shade up here. And now we're finished. We're done. So do you understand how to know where to shade? You have to test the point. Now, let's pretend this point would have been true. If that point would have been true, then you would shade where the point is. So you would shade down here, not up here. Okay? It all depends on whether the point that you test gives you out a true statement false statement. That's really what it depends on. Let's try one more, and I think you'll be ready for your homework, okay? Here we go. I really don't have a problem picked out. Let me look here and try to find one that's a little different here. Alright, let's try this one right here. Negative 2x plus 6y is greater than or equal to 12. Alright, now the first thing you should notice is you have how many variables? 2. If you had one variable, then you would get the variable by itself and then draw your vertical line or your horizontal line and then shade. Whenever you have one variable, the problems are pretty easy. They really are, okay? When you have two variables like this problem here, then it gets a little more difficult, alright? So the first thing you should notice is we have two variables. So then you say to yourself, okay, I'm going to graph the line. So even though I don't have an equal sign, I'm going to pretend that I do, like this. How would I graph that? Well, I would put 0 in for x. 2 times 0 is 0. 0 plus 6y is 6y. So obviously, y equals 2. So the y-intercept equals 2. Now let's put 0 in for y, okay? We put 0 in for x, that gives us the y-intercept. Now we're going to put 0 in for y, and we're going to get the x-intercept. 6 times 0 is 0, negative 2x plus 0 is negative 2x. Divide both sides by negative 2, and x equals negative 6. So the x-intercept equals negative 6, alright? So we are now ready to graph this line. X-intercept is positive, or the y-intercept is positive 2, and the x-intercept is negative 6. Now am I going to draw a solid or a dotted line? Well, look, I have an equal sign here, do I not? Sure I do. So I'm going to draw a solid line, and that's not a very good line, is it? Try it again here. Not a whole lot better, but it'll have to do. So there, I've drawn my line. Don't forget to always check whether or not you have a dotted or solid line. Now, here's my dilemma. Do I shade above or do I shade below? Let's test 0, 0. And let's see. So I'm going to test 0, 0. So everywhere there's an x, I'm going to put a 0. Everywhere there's a y, I'm going to put a 0. Let's see what I get out. 2 times 0 is 0. 6 times 0 is 0. 0 plus 0 is 0. 0 is greater than 12. Well, there we go. 0 is greater than 12. So this ordered pair right here, 0, 0, is false. It does not work. So if it doesn't work, why would you shade down here? Or the false point is it doesn't make any sense. You would shade where that point is not. So you would shade up here. Okay? Now, if this point had given you out a true statement, then you would shade where the point is, which is down here. But that did not happen. So your final answer is to shade up here. So all of these ordered pairs up here, all of these ordered pairs, the shading would go on and on and on. All of these ordered pairs are solutions to this inequality right here. Alright? And students, that's how you graph inequalities on the coordinate plane. Okay? If you have any questions, I hope this video has been helpful to you. If you have any questions, don't hesitate to call or email.